thank you, Juan, thank you, Alex, for the very nice introductions. Obviously, it's a great honor to receive this award. I also have to thank Mike Ball for all the work he put in the nomination and the selection committee for their wisdom. What I would like to do for you today is give you a little bit of an overview of part of my research, particularly eye-tracking research on advertising. But before I do that, there's something that I have to set straight, literally speaking. You may have seen that the eye on the poster, it is actually upside down. And so for those of you who have not seen that, maybe this talk will explain to you why you haven't noticed. So if we teach advertising, many of us in the marketing department, we like to always start with a quote. It's probably the most used quote in advertising research. Yeah, half of the money spent on advertising is wasted. I don't know which half. That was John Wanamaker. Now if we use this quote in our teaching, we have to realize that John Wanamaker was a very successful businessman who died in 1922. And so this quote is presumably 100 years old. Now you have to think about the type of advertising John Wanamaker was talking about when he said this. So this is what an ad looked at that time. You see there is a product logo. I'm going to use, there's a product logo here. Okay, on the top you see the product logo. It's an advertisement for shoes. You see the shoe, there's a pictorial, and there's a lot of text. Now the question is, have we made any progress in the last 100 years, and is advertising now at least more successful than that has? So this is what an ad may look like for shoes right now. So the question is this more effective or not? And to know whether this type of ad is more effective, we need to take a closer look at how people look at those ads. And to do that, I have to take you back to your high school days. So this is a cross-section of the human eye. And what you see here is a pot of Hellmann's mayonnaise, which is projected through the cornea, which is the outer layer of the eye, through the lens on the back of the eye. The inverted image of the mayonnaise on the right-hand side is the image projected on the back of the eye. Now the back of the eye is called the retina, as you may remember, and it's a very sensitive layer of neurons. The rods and the cones are there. The rods are sensitive to light. Cones are sensitive to color. Now what is important to note is that the retina is not equally sensitive everywhere. In fact, it's only very sensitive in the small center. That small center enables you to see things with very high acuity. If you would put out your thumbnail at arm's length, thumbnail like this, you stare at the nail, this is the only thing you see perfectly clear, and that's about the size of the macula, or the center of the eye. So most of what you see out there in the real world, you really don't see very clear. The cells in the periphery of the retina also get bigger and bigger, and in fact in the far periphery, you don't even see color at all. This has a very important consequence, because to be able to see out there in the real world and to look at ads and shelves and so on, what we have to do is we have to move our eyes. We move our eyes with 6 muscles that are connected to the eye, 2 on the top, 2 on the bottom, 2 other ones that sort of help to rotate the eye. You see the top and bottom muscle in the graph here. So if you contract those muscles, the eyes move up. If you contract the inner one and the outer one here, the eyes move left or right. Now, this might not come as a big surprise, because we know all that we move our eyes, but we have the impression that when we move our eyes, we do this in a very smooth fashion. And the way we look into the world, we have the impression we see everything very clear at all times. That's very far from the truth. The way in which we move our eyes is in very discrete types of eye movements. So there are 2 types. The first are called circades. Circades are very quick ballistic jumps of the eye from one location to the other. They last around 20 to 50 milliseconds. So 20 to 50 milliseconds it takes your eye to jump from one location to the other. During a jump of the eye, you're functionally blind. You don't see anything. If the eye jumps, the brain suppresses the incoming information. Why? Well, you become very dizzy very quickly if it wouldn't, because the jumps are very, very fast. You make around 150,000 of those movements a day. So 150,000 times a day, you're blind for around 20 to 50 milliseconds, which adds up to around 50 minutes per day that you don't see anything. One reason why you shouldn't be texting and driving. During a fixation, the eye is still. The eye doesn't move. Information is extracted from whatever you look at. Lasts around 20 to 50 milliseconds. Contrary to what you might believe, you cannot control the duration of a fixation. So during a fixation, the eye is relatively still, it moves a little bit. If you think you're staring at something or somebody, what you're actually doing is refixating. You have to refixate all the time. If you were not able to do that, then the eye would be perfectly still. You wouldn't see anything within maybe half a second to a second because the retina responds to small changes. So the question, what we're really interested in are those fixations, those short periods of time where the eye is still and where information is extracted. So the question is, what do you see during such a fixation? The first fixation on that shoe ad that I showed, you might see something like this, and this is actually very likely what you would see. The first fixation often lands in the center of the stimulus that you're looking at, and about 2 degrees of visual angle would give you this, this view. So most of the ad you actually would not see in the first, let's say, 300 milliseconds. The coarse layout of the ad will give you some information that this is in fact a person, which makes it then very likely that your second fixation would land on the face. Still, you would have no idea, perhaps even that this is an ad, and you would have no idea that this is an ad for shoes after about half a second. So let's take a look at an eye movement pattern. So what I'm going to show you is this particular ad. We're going to show you how a person moves his or her eyes across this ad. The blue dot that you see is the point of fixation. And so you'll see that blue dot move. The lines between the blue dot are saccades, or jumps of the eye from one location to the other. As the dot gets larger, the duration of the fixation increases. So this lasts around 2 to 3 seconds. The average ad in a magazine gets an exposure of around that duration, only 2 to 3 seconds. So the important question is, of course, what can ads communicate in such a short period of time? But more important, how do we measure those eye movements? So this is, these are two sets of eye tracking equipment. If you look at the top image, this is an eye tracker that's a clip-on eye tracker that you attach to a computer monitor, a shelf, or any other stimulus. What the eye tracker does, it emits infrared rays that reflect off the cornea, the outer layer of the eye, and it creates a little image that is picked up by cameras. The cameras do that depending on how good the eye tracker is, between 50 times and 150 times a second for most commercial eye trackers. The cameras also record the position of the person's head. So the person at the top is actually free to move his head in front of the monitor within a box of around 1.5 by 1.5 feet. The bottom eye tracker here is a mobile eye tracker where there's a camera embedded in the front of the glasses that captures the field of view, and there's 2 miniature cameras that capture the eye movements within the field of view. We're currently upgrading our behavioral ad, thanks to a generous support of the previous dean, Anand. And we're getting 2 new eye trackers, which are probably one or both of these. The progress that has been made in eye tracking is literally enormous. If you look at how eye tracking was done, maybe just around 50 years ago, people's hands had to be fixed. There's a bite bar, there's lenses in front of the eyes, and so on. Eye tracking really was not as unobtrusive by far as it is now. There's even some eye tracking devices where a coil was inserted in a lens that was put on top of the eye, which is not entirely without any pain or risk. So some researchers were only able to do this with their spouses. So let's take a look at what the eye tracker produces. So this is an image of an ad for a car, and this is an eye movement pattern which we call the scan pad. So the scan pad starts usually somewhere in the center. The dots are fixations, and the lines are Circades. You see, this person starts in the center, explores the car, and then reads at least part of the text. Now you might think that you would look at this ad very differently. Partially true, maybe partially not true. So this is a sample of 100 people looking at these ads. And of course there are some differences, but you also see a lot of similarities. And this is actually what advertisers want. Advertisers want to grab people by the eyeballs and guide them across the ad in a way that is convenient for them. So there's lots of similarities which are caused by the design of the ad itself. There's also differences, and you can imagine that sort of analyzing this type of data is not entirely a trivial task. And analyzing spatial temporal data of this nature can be quite challenging. So are we the first ones to use eye tracking? No. Eye tracking is used in lots of different fields and has a very long history. In fact, the first eye tracking study that we know of in marketing is a study in 1924 by a psychologist called Nixon. He looked at print advertisements as well. There was no eye tracking device, so what he did is he put a cloth over his head, had people look at ads, and make notes very quickly. I mean, it really has to be very quickly if you think about 20 to 50 milliseconds a K about where people look. Some of his results are actually very interesting and still hold today. Many companies in the world use eye tracking data, and I've noted a few examples that I know. P&G, IBM, Kraft, Pepsi, Target, Google, and many of those companies. We have someone of Pepsi, Tony is here. See where he is right now. If I'm not telling you the truth, if I'm not saying the truth, then please feel free to correct me. So many of these companies actually have eye tracking labs themselves. Others buy the eye tracking data from suppliers, such as PRS. PRS is Perception Research Services. Is probably the leading eye tracking company in the US and in the world. We just had the president of PRS give a guest lecture in our marketing analytics class last week, Scott Young. So what is interesting about this is that this is very widespread, lots of data is being collected, literally thousands of studies are being done every year. And what we have found interesting is that many of these studies yield unique insights that you can't really obtain otherwise. It's very hard for us to come up with hypotheses that predict how we move our eyes, because many of the eye movements are actually close to introspection. We can't really have any idea, we can't really think about how we move our eyes and what we look at. In addition, as I hope to show you, several of those studies have very important actionable implications for practice. So this is the framework of the research that I've been doing on eye tracking in the last roughly 20 years. What we're interested in the center of this figure is visual spatial attention. What we're interested in is what people attend to. Now there's a very tight coupling between attention and eye movements. People move their eyes to locations on ads and other stimuli that they attend to. We're particularly interested in two factors that may influence visual spatial attention, which is things that have to do with the people and things that have to do with the stimuli, with the ads. We call those bottom-up stimulus factors and top-down factors. And perhaps even more importantly, we want to know how does this affect, how does these attention patterns affect how people search for brands on shelves, what kind of choices do they make, and how much products companies end up selling. So these are quite challenging tasks, and for that we need data, eye tracking data. Usually eye tracking data is very large. Think about a sample of 150 respondents, which is not all that much, looking at 50 ads. You know, if the average magazine has 100 to 120 pages, half of those are filled with ads, so 50 ads is not that much. You sample at a frequency of about 150 times a second, which yields around 3 million data points. Right? And that's not a very extensive eye tracking study at all. The eye tracking data itself is not sufficient to come up with manageable conclusions. What we need is theory, and many of the theories are either derived from the marketing insights or from cognitive psychology, and we need statistical models as well, where we use these theories to make inferences on specific aspects of the eye movement process. So in order to accomplish all of that, we combine literatures on vision, attention, statistics, and algorithms. Now, the methods that we have used mostly are Bayesian methods. And the Bayesian methods originate from a theorem that Thomas Bayes came up with in the 1700s. Bayes' theorem is essentially a formalized way of learning about new information. It tells you how you should be changing existing beliefs in the light of new information. For a long time, these methods were really not used all that much. The reason being that they were kind of unwieldy. So many of the results were really hard to obtain, or in some cases, in many cases, even impossible. The popularity of these methods really increased in the 1990s when sampling-based methods became available to make inferences. So rather than having closed-form solutions, sampling techniques were used to come up with estimates of parameters and inference. Now that Bayesian framework has many advantages, and I won't go over all of them. It deals with missing data and outliers very easily. It deals with latent variables. It can deal with many integrated model components that you can just stack on top of each other. It can deal with unobserved differences between individuals. It can deal with hierarchical data structures where some information is available on ads, others is available on individuals. And most importantly, it can deal with optimal decision making. So the Bayesian framework, once you've estimated models, will allow you to support optimal marketing actions. So this provides a very robust and flexible framework for formulating and estimating statistical models, in particular those relating to eye movement. Now for some of you this may come as a big disappointment, but this is all I'm going to say about the Bayesian methodology. What I'd like to do next is focus on some of the results that we got on our research on print advertising. And I'm going to give you 10 insights, and I hope you'll be able to reproduce at least 8 of those to get a good grade. So one question that some of you might have is, why don't we simply ask people? So rather than buying these eye trackers, which are much cheaper than they were before, but they're still around $30,000 each, why can't we just ask people what they saw? And in fact, this is what companies have been doing for a very long time. This started in around the 1920s when a person called Daniel Starch came up with the idea that you could expose people to ads and say, hey, did you see this ad before? I could ask you this for this particular ad. Did you see this ad before? If you saw it before, did you saw the picture? If you saw it before, did you look at the brand element of the ad and did you read most of the text? Now one thing that we've done is look at whether this type of recognition measures actually has validity. So if people look at ads, does it really predict what they remember? The answer is yes. there is definitely a relation between what people look at and what they remember post-op. At least as it comes to the picture and the brand element. We were not able to find any relation between whether they read the text or not and whether they remember to have read the text. Which is kind of worrying because these recognition measures then have nothing to say about text. The size of these elements, so if you think about an ad being composed of a pictorial and a brand and text, the size of these elements directly affect recognition even beyond what people have looked at. What that means is people are using the sizes of these elements as heuristics to make inferences themselves on whether they've seen the ad or not. So if you have an ad with a large picture, people think, hey, the picture is large, so probably have seen the ad, and maybe I've seen the picture too. And this creates a bias which is actually very, very strong. So let's take a look at the eye movements per se. So let's get back to the John Wanamaker quote that half of the money on advertising is wasted. So one reason that this may have been the case and may still be the case is that many ads, in fact a large proportion of the ads, do not receive more than a single fixation. So I told you that most ads in magazines at least get looked at for around 2 to 3 seconds at most. But the vast majority gets only one single fixation. Now that one single fixation lasts around 200 to 300 milliseconds. So major question for advertisers is that money wasted on all those ads that just get a single fixation? Think about when you flip through a magazine. Or can we still communicate something within that single fixation? It turns out that indeed people can grab the gist of typical ads within such a very short exposure. And you have to remember that these exposures are not only short, but they're also very coarse. The reason is, within a single fixation, most of the ads you really don't see. And in addition, you might be flipping through the magazine very fast or driving past a billboard or otherwise in a very impoverished exposure condition. So ads indeed are able to communicate something. They can communicate the product category in 95% of the cases correctly within such a short period of time. Communication of the brand is less. It's around half of that, but still that's actually quite impressive that people are able to grasp the gist of the ad in such a short period. The caveat is it doesn't work for all ads. Not all ads are able to do this. The ads that actually can do this are the ads, you see that in the bottom bullet point here, are ads that are typical. Only ads that are typical communicate very, very quickly. Now what are typical ads? If you look at the graph here, if you look at the left-hand side, these are drawings that consumers make. You say, hey, what does a typical car ad look like? What does a financial ad look like? What does a food ad look like? And so on. The ads in the center are typical ads. And you see that a car ad, what should a car ad look like? Well, it has a car in the center, should have some mountains in the background. A skincare ad should have a face of a person. Now, ads that do not conform to this typicality template might be useful in some settings, but are definitely not useful in situations where the exposure durations are very, very short. So here, typicality works well. Maybe a bit of a disappointment for some of the creative people in advertising agencies because they get awards for being non-typical. So let's take a look at, so this was the first fixation. Let's take a look at going beyond that first fixation. One of the things that we found is that if people look at ads and many other stimuli, what they do is they break up the task into a series of local tasks. In fact, looking at something as complex as an ad, so this is an ad on the left-hand side, on the right-hand side you see the editorial counter page. This is a very complex stimulus to comprehend and to determine whether it's interesting for you or not. So what people do is they alternate very quickly between two states. One state is what we call the localization state. Hey, is there information in there which is relevant for me? And the identification state, once they found something, they try to identify what it is. So in this graph, the red bars are localization fixations, The green bars are identification fixation, where people are trying to identify what it is. Why is this important? Because people have typically assumed that if you look at ads, you first have a stage of global exploration, where you're trying to find out what is there, then followed by local identification, trying to identify brands and ads. Turns out that we couldn't find any evidence for it. It's really a sequence of global followed by local explorations, where people try to break up this complex task into smaller subtasks. So let's take another look at the scan path. As I mentioned to you, many advertisers are interested in sort of trying to grab consumers by the eye and guide them across the ad. So it would be important to find a certain stability of the scan path. So the ad that you see on the right-hand side is in fact an ad for Mercedes, and the logo of Mercedes is embedded in the mold on Marilyn's cheek. You see the scan path of one consumer. So if you expose consumers multiple times to the same ad, which happens a lot in real life, obviously, the exposures get shorter and shorter over time. You see that's illustrated for 3 ads: dark blue, light blue, and yellow. So at every subsequent first, second, and third exposure, the exposure duration reduces by about half, which means the final exposure, if you start at around 2 to 3 seconds, the final exposure really is very, very short. However, the scan path stays, at least statistically speaking, the same across those exposures. And so people, at every subsequent exposure to that particular ad, people traverse the ad with their eyes pretty much in the same way. It has been thought before that this is a memory effect, so that people would store not only the ad in memory, but also the scan path. It's probably not true. Actually, it's very likely that what causes this effect is that the ad is very well able to grab people by the eyes and move them across the ad in a way that's desirable to the advertiser. If you get exposed to the ad multiple times, the ad does so multiple times, but you do it just faster and faster. The question is, if ads are good at doing that, are there differences between individuals? Are people different in the way they explore these ads? And in a study that I present the results of here, we looked at groups of consumers or segments of consumers that have different attention patterns. And we found, in this case, for this ad, we found 3. So the first segment looks at essentially the headline and the pictorial and nothing else. The second segment looks at headline, pictorial, and pack shot. The third segment looks at headline, pictorial, pack shot, and the body text. So it seems that these segments indicate different depths of processing. And in fact, they correlate quite highly with people's involvement with the ad. The more involved you are with the ad or with the product category, the longer you look. So the gaze duration increases from left to around 0.6 seconds to right about 3 seconds. So gaze duration increases, and people on the right are also more involved than on the left. So individual differences are really very important in looking at ads. And in much of our research, we actually built these type of individual differences into the models that we estimate. Now, one reason that people might be different is that they might have different goals. So in this study, we look at the effects of goals on attention patterns. And we gave people different goals. So the graph here shows the control situation is free view. So we ask people, just look at the ads in any way you want, like if you're in a waiting room or at home. Ad memorization is try to remember the ads that you see. Ad appreciation, do you like the ads or not? Brand learning, try to learn something new about the brand from this ad. Brand evaluation, do you like this brand or not? Now, the attention patterns that you see in those conditions are actually markedly different. When people evaluate the brand, top bullet point there, when people evaluate the brand, they look most at the body text. If they're asked to evaluate the brand, they look most on the body text. Why is that? Well, they probably believe that most of the information on the brand is contained in the body text. When they want to learn more about the brand, they look more at the body text but less at the pictorial as compared to that free viewing condition. So they suppress information to the pictorial because consumers might have the idea that pictorial information is more to make the ad look nice rather than it containing real information on the brand, which is not true, by the way. Lots of pictorials and ads actually do contain information on the brand. When they try to remember the ad, which is the bar here, first of all, they look much longer. And then they also look much longer at many of the components, both the body text, the pictorial, and the brand element. So the goals that people have when they look at these ads really affect the attention patterns in a very dramatic way. What is perhaps interesting is the difference between the control condition and ad appreciation. There's none. And so if you ask people to explore ads freely, what they may actually be doing is evaluating the ad. Okay? If you explore them, they say, do I like this ad or not? Question is, what can advertisers do to change these attention patterns? One thing that they have done, and is actually very important, is changing the sizes of these elements. So most ads consist of headline, pictorial, brand, and text. And companies actually have specific guidelines on how big those elements should be. Some companies say, well, we shouldn't really bore our customers with our brand too much and it should be very small. Others say, well, we should have it very big and in the center and so on. So in a very large study that we did, we worked with a company at that time in the Netherlands where we collected, they gave us eye tracking data from close to 1,500 ads and around 7,000 or 8,000 consumers. We looked at the effects of the sizes of these ad elements. Now what many people believe, and many advertisers believe, is pictorial is important. Making the pictorial large is better, and once you get attention to the pictorial, the attention will then carry over to the brand and the other elements. It turned out that we didn't find that at all. The pictorial is important and attracts attention immediately, but making the pictorial larger doesn't really get you much more attention. And so there's not much of a benefit in making the pictorial and advertising larger. The reverse holds for the text. So text size, increasing the size of the text, so not the font, but just putting more text in ads, actually increases attention not only to the text element, but also to the ad as a whole. And in fact, the only way to increase attention to the ad as a whole is to make the text bigger. The brand element is very interesting. We found a very central role for the brand in advertising, attention to advertising. Attention to the brand increases very strongly with the size of the brand, and much more so than for the pictorial. And once attention is captured by the brand, it carries over to the picture and the text rather than the other way around. And so the brand is front and central in advertising. In addition, attention to the brand promotes memory most. As you look at if attention to text, pictorial, or the brand promotes attention, it's brand really that has the biggest effect on whether people remember the ad later or not. Now there's other ways, just changing the sizes of these elements is perhaps not something that is the most imaginative, and creatives and advertising agents try to make ads original, and those are typically the ads that are award-winning. So we looked at the effects of originality of ads. And what we found is that making ads more original increases the attention or the gaze on both the brand and the pictorial. So original ads, people look more at the brand and the pictorial element of original ads. That effect is even stronger for familiar ads and brands. So if the ad is more familiar, the effect of originality actually gets more pronounced. And in addition, it helps memory for the brand. So that's a double whammy. Making ads original affects the attention patterns in a way that is desirable, but it also helps remember the brand better later on. However, making the ad more original might also make it more complex. So the question is, what is the effect of complexity on attention patterns to ads? It turns out there's two forms of complexity. One form of complexity is what we call feature complexity. And feature complexity essentially means there's lots of colors and edges and fine-grained detail in those ads. It turns out, this is my signal to, I feel like you're turning away. So feature complexity in fact hurts attention to the brand element. So if you make ads more complex in terms of the basic features, you see an example on the right-hand side versus the left-hand side. So the left-hand side top is an ad that is not very complex in terms of the basic features. The right-hand side is very complex. Attention to the brand is affected negatively when the ad is more complex. Essentially it becomes more difficult to find that brand element. It's very easy to measure feature complexity. It's just the file size of the ad image on your computer's hard drive. There's another form of complexity, and that is design complexity. And this is something that advertisers can actually manipulate. So by designing ads to be more complex, you would have to have more objects, more asymmetric objects, more irregular objects, and so on. And if you do that, it actually helps attention. So design complexity, an example is the right-hand side ad on the bottom versus the left-hand side. Design complexity in fact helps attention to the pictorial and the ad as a whole. So by making ads more complex, you have to keep in mind those two potential effects. Now finally, we looked at feature advertising, or freestanding inserts as they're called in the industry. So what are freestanding inserts? They're ads that are being placed by the retailers in magazines or in flyers that feature lots of different small ads and products. Now, they're not really an ad, they're in fact sales promotion tools because their intention is to boost sales in the very short run. They don't intend to build brand equity over the longer run or brand awareness. Now, what they do is they say, hey, here's a brand, this is the price, go to the store and buy it tomorrow. The question is, are these, so here you see that advertising suffers from clutter in general, but in this particular case the clutter is quite severe because there's many little ads on the same page and they compete for attention. So the question is, are these ads designed optimally? And so what we did in this research is we built a model, and then based on that model of attention, we actually optimized the feature, each of the individual feature ads and their location in the page. We did that across around 1,200 of those feature ads, and again, there's a sample of around 10,000 people that we were able to obtain because of working with a company that provided us with the data. First thing that we found is that the optimal feature ad page has a much smaller pictorial than the current versions. Why? Well, it might be that people use starch tests or other tests that inform them that larger pictorials are good. Right, so in feature ads, again, we find that pictorials are generally too large. They should be smaller. What should be larger? The brand and the price element. People are looking for brand and price. Those elements should increase. In fact, in doing so, you will help not only the retailers' brands, but also the manufacturer brands. Manufacturers pay retailers to be featured on these pages, but because the retailer tries to feature its own brands with large pictures, it hurts not only its own brand, but also the manufacturer brand. So designing these pages optimally will help both the retailer and the manufacturer. In addition, what we did, the question that we get many times is, okay, it's good, you show that people look at stuff more, but really does it have any interesting downstream effects? So for this very large sample of ads, we collected data in the Netherlands, national level data in retail outlets on sales of each of those products in the same week that those feature ads appeared. And it turned out that we were able to find a relationship between the gaze on those feature ads and sales, over and above the mere presence of the feature ad. So if people look at more at those ads, indeed, sales at the aggregate level, at the national level, do go up. So let's take a look at what's next. So these were my 10 lessons. Let's take a look at what's next. Eye tracking is moving very rapidly, and there's all kinds of new developments. One very interesting new development is that eye tracking is now possible through front-facing cameras. So the cameras that you have on your iPhone and your computer are actually able to do eye tracking. Admittedly, it's not yet as precise as the eye trackers that use infrared. It's hard to do it as precise, but they will and are currently already integrated in computers, billboard kiosks, smart TVs, and smartphones. So one thing that it will enable us to do is to actually do very large-scale eye tracking studies. There's a company based in New York that's actually already doing that over the web, where people sit in front of their own home computer, look at the screen, look at the stimuli, and you can have very large samples of individuals, which sort of offsets the problems of precision a little bit. More than only collecting eye movement data, it will also support all kinds of hands-free access to information. What you can do is you can provide support for all kinds of tasks that people have interacting with these electronic devices. You can improve online shopping experiences, because if you can record what people are looking at, you can enhance the type of information that they're currently looking at. Same holds for keyword and image search. Keyword and image search is very static. As soon as you're able to record people's gaze on specific types of information that they're extracting, you can enhance that information visually and make it more important. There's already applications in education and gaming. Why do I have that picture of the lady up there? This is a mannequin that is manufactured by an Italian company that has eye trackers embedded in it. It also has voice recording. And so as soon as people pass by the mannequin and they say, hey, that's a nice dress, and they look at specific aspects of the dress, or they say maybe the color is not optimal, signals are being sent back, salespeople come up, and they will interact with So gaze contingent rendering of information is really key. You can help people read text. If you don't understand specific aspects of text, which is indicated by special types of eye movements, you can enhance the text or show pop-ups saying, hey, you didn't understand this is what it means. You can enhance product placement. Product placement is a big problem, because people often suppress the information or miss it. If you know what people are looking at, you can improve product placement. Organic and sponsored search results can be enhanced in all kinds of ways. Better display ads on web pages and interactive billboards. There are already billboards where you can actually interact with the billboard. The billboard records your eye movements as well as your body movements, and the billboard reacts to whatever you look at and whatever you do. So I think I've shown that eye tracking is quite effective for the evaluation of visual marketing. In addition, it's also fun to do. And those of you here who have worked in the eye tracking lab and experienced hands-on, it provides very unique data on how consumers process information in looking at a very wide variety of marketing stimuli. Obviously, we have not only looked at advertising. We have looked at many other types of stimuli. We looked at search on shelves, so try to improve shelf search by better product placement, shelf design. We looked at the gist perception of copycat brands. So how is it possible that people confuse brands in front of the shelf? We've looked at optimal brand placing in TV commercials. We found that pulsing is a strategy which is very good. So rather than having a commercial where nothing is shown for 25 seconds and then the brand is shown in the last 5 seconds, it's much better to have the brand present many times at very short intervals. We look at facial emotional expressions. We record people's facial expressions and look at their emotions while watching TV commercials and movie trailers. We look at decisions on shopping and comparison websites. We started to work with the medical center and the mathematics department to look at how people, and these were laymen, search for nodules in chest X-rays. So potentially cancerous nodules, it's very hard, obviously, to detect even for experienced radiologists. Image processing tools that they use often show up many positive results, which makes search harder rather than easier. What we show is we can have laymen, in fact, business school students, search for these nodules and then use statistical models to tease out the specific points of interest where there's potential problems which can then help radiologists in better diagnosis. We have a state-of-the-art eye tracking lab, my little ad for today, so I would invite all of you who are interested to use it, especially once we've upgraded it to take a look. It has been a resource for faculty in various departments in the Smith School and outside of the Smith School. Other departments have also made use of the eye tracking lab. It's a great resource for students, not only PhD students, but we had several MBA students and master students already who have worked in the eye tracking lab and have collected data. It's there. Make sure you get on the calendar and just try it out. It's definitely fun to work with. So, last slide. Thank you very much for recognizing my teaching and research. Thank you very much for showing up. It's never the same without the audience. And thank you very much to my collaborators. Obviously, I have to emphasize this is not only my work. There's many people over the years that have collaborated with me, both students and faculty, and I'm very grateful for the work they have put in over the years. I don't know if we have time for any questions or remarks. Thank you.
Questions? Yes, sir.
Yeah, I'd like to ask something. This pertains to your very impressive work, but also the whole marketing department. Do you people have qualms, any moral qualms, about using this great expertise and all this research in order to help people manipulate consumers or people into doing what they want them to do? Remember that people were writing ads for cigarettes long after it was clear that cigarette smoking was harmful. I also say, if you just give me a minute, that marketing, marketing is killing the United States of America. It is killing the United States of America. Now, the worst day in the history of America is not 9/11, it's not Pearl Harbor, it's not the day Kennedy was assassinated. It was the day that somebody realized that you could market political candidates in the same way you could market toothpaste. And this is the root of all our problems today with our government.
Well, I think you raised a lot of interesting points. So let me react to that. And I think this is a very serious issue. What we as marketeers in business schools are trying to do is trying to have companies better meet the needs of customers. And so what we are not trying to be, it would be, in fact, I should have had another quote of John Wanamaker up there, because one of his other quotes, and I cannot phrase it directly, but one of his other quotes is, putting deception in advertising is as bad as the deception itself. Deception backfires. And so what we in marketing departments try to do is teach companies to better meet the need of customers. And much of marketing research and the frameworks that we provide actually hopefully help companies do that. Does that mean that the practice of marketing, we don't practice marketing, we research marketing. Does it mean that the practice of marketing adheres to those standards? Unfortunately, not always. The way that medicine is being taught in medical schools, unfortunately, is not always the way it's practiced in real life. And so do people in the medical schools have to take responsibility for the errors that are being made in practice? Absolutely, which is definitely what we do. And so it's our task to better educate our students and we have many courses not only on marketing, but we have courses on business ethics and the ethics of marketing. And what we try to do is actually improve exactly the problem that you're addressing, so that's why I'm very happy with that question.
I have a question about the feature ads, the FSIs. So you mentioned that the longer the gazes, the more likely they are to purchase product. How do you account for predisposition affinity for the product?
In most of our studies, we put in all kinds of controls. And so we correct for people's familiarity with the product, we correct for previous purchase occasions, we correct for effects of price and other promotions and so on. Do we complete, I mean, what you're saying is there's people that would buy the product anyway, no matter whether it's advertised or not.
No.
Or maybe it's more effective for people that
Right. They might look at the ad longer because they already have.
so that's exactly what I showed in that slide on segmentation. Right? So
Right.
people that have more involvement with the product will be more inclined to look at the product longer. The sales effect is an aggregate level effect, and so it basically means that across all people in the Netherlands that saw one of those feature ads potentially, there was an effect on sales. Some of that may have been caused by people that wouldn't bought the brand otherwise. Others might have been caused by people that would have bought it. But regardless of the underlying causes, which we couldn't tease out because of the aggregate nature of the data, the aggregate effect still stands, controlling for as much as we possibly can.
I'd like to respond to the gentleman over here who was talking about marketing of political candidates as being similar to the marketing of consumer products. And as somebody who spent most of my career in advertising and who has handled political candidates, there is a big distinction between commercial free speech and political free speech. In commercial free speech, you are not allowed to lie. In political free speech, you can say whatever you want. So that's the Bill of Rights. And that doesn't mean that marketing is unethical. It's just commercial free speech has different rules than political speech.
Thank you for the addition.
So, thank you, Michel. That was very, very interesting and insightful. I guess my question is a little bit futuristic, and I wanted to get your thoughts on how far away are we, or are we already there, where you're really doing microsegmentation in real time for both copy as well as the visual display of ads, and you know you have an algorithm running in the background that's essentially learning every time I'm on the web consuming some information.
I mean, some of this is being done in some applications, so it's not currently widespread yet on the web. It's being done, for example, in gaming, gaming applications. So there's definitely places there. There's applications in education and schooling where children's reading behavior is improved based on the gaze patterns that they have. You know, Google has actually a patent out where it will charge advertisers based on gaze through Google glasses.
Right.
And so we're definitely moving, I think the new Motorola cell phone has eye tracking embedded. It's somewhat rudimentary, it's very hard to do at that scale. But so I think we're definitely, I said 3 to 5 years, it might actually be much faster than that because things are really moving quite fast. I think it's a very exciting area to actually be able to in real time, optimize websites, banner ads, and all.
Our motivational messages, depending on what you want to send.
Yeah.
Right.
We'll take one more
One more
question.
question.
Yeah, in slide 2, you mentioned that typical ads are most easily recalled and read. And then in slide 8, you mentioned originality in advertising, improved attention, and memory. And at first listen, that sort of sounds contradictory. Could you clarify that for me?
Yeah, so the difference is that the first slide I was talking about that first fixation. So what you have to keep in mind is that many of the ads that we see in practice, and in fact a lot of the advertising research in academia, deals with long exposure durations. People are exposed to an ad for 10 seconds, sometimes 30 seconds or more, and then being asked questions about the ad and the effectiveness of the ad. The point we're trying to make in that first slide is that there's lots of situations where people really don't, in fact, the vast majority of situations where people don't get exposed to an ad 10 seconds. So that first slide is about what happens if people just skim over a magazine and fixate only once on a particular ad. In that situation, typical ads work very well. If you're in a context or a type of product where you have more consumer engagement and the exposure duration is longer, that's a situation where originality and complexity might actually work. But people have to be willing to spend the additional amount of time to process that information. So depending on the nature of the exposure condition, different types of advertisements.
Thank you. Thank you so much, Michel. This is clearly fascinating work, and you did such a beautiful job exposing it. Truly a scholar and teacher. So thank you so much. And I believe